So, what is mechanics? Mechanics is a science which describes or predicts the state of a body in motion or at rest. So let's see what that means. He said it predicts the state of a body. Assuming this body is at rest, this stuff is at rest here, right? So dynamics will study the forces that causes this body to be at rest, and if it moves forward, you see I'm pushing it forward, it also study the force that causes this body to be in motion. So that is basically what applied mechanics entails. So in this aspect, applied mechanics is the ability for us to understand these forces on how it works in a mechanical system and use it to create a functional mechanical system. Okay, so basically the mechanics is divided into two: the statics. Mechanics is divided into statics and dynamics. So basically, statics has to do with the branch of mechanics that study body, the forces that keeps a body at rest. So this book right now is at rest. The forces that causes it to be at rest is what statics takes into consideration. While dynamics is a branch of mechanics that studies a body, the forces that cause the body to be in motion. Okay, so dynamics is a very important aspect of applied mechanics. So also the statics. We see that the dynamics is further divided into the kinematics, and kinetics. So kinematics basically is that branch of dynamics that study body motion without considering the forces that cause them. So this marker moving, we don't care if this marker moves from here to here. It doesn't care how it moved there, what made it to move. What it cares, it doesn't care about the road to success. All it cares is how did you get to position there. You got to position B. That is the business, not how. You just got to position B. That's okay. But kinetics takes into consideration the force that causes this body to accelerate, the force that causes this body to move from here to here. So that's what kinetics takes into consideration. So we move into the next thing called concept of mechanics. Concept of mechanics. It is divided into, there are many concepts, but we are going to look at these four common concepts that we need to understand. The first is the mass, that's the mass of the body, the quantity of matter in a body. That is what mass is. The time of the event, the time at which this motion occurred, or at what time is an event occurring. Force is the interaction between two bodies. How two bodies interact. That is forces. And then we have space. Space is the region of occurrence, or the region at which a point moves. The region at which a point moves. That's basically what space is. So these are the basic concepts of mechanics. Alright. Let's look at another concept what we call scalar and vectors. So we can't do anything in mechanics without understanding two concepts: how quantities are being divided, how quantities also exist. So basically, quantities exist divided into two, or exists in two forms: scalar, or it could be subdivided into two forms: scalar quantities and vector quantities. What are scalar quantities? Scalar quantities are those quantities that has only magnitude but no direction. So this guy has magnitude, zero direction, while vector quantity has both magnitude and direction. Take note of that. So a vector has both magnitude and direction, while scalar doesn't. So how do we represent vector? Assuming this is a particle, we can represent this particle using a letter. I could call this letter A. So basically, to represent this, to show that this body is a vector, we write it like this. The arrow on the top shows that it's a vector, that it has direction. Okay, so therefore, how do we write magnitude? Because we said it has both magnitude and direction. This is how we write magnitude. See how we write magnitude? Magnitude can be written as thus, like this, or like this, basically. So as easy as that. So this is how we can write magnitude, or we write it normally, not with the bar. The bar there is if we put two bar there, it's wrong because it shows absolute value. So this is the right way of writing magnitude, and this is the way to give that is a vector showing a direction. So the combination of magnitude and a direction. Okay, moving on. So basically we are focusing on vector now. What is a free vector? What do we understand by a free vector? Basically, free vectors are those vectors that have magnitude and direction and can move anywhere in space. Meaning, if this is a space, of course it has magnitude and direction. It will move anywhere in space. It can move like this, but in a specific direction. Alright. Now, what we have been considering as vector is if we are we're looking at when vector, a particular body is a vector. Now, what happens when two vectors come together? How can we add them? Now, assuming we have these two vectors like this. Assuming we have these two vectors like this, we call this P, we call this Q, right? We can add this using three methods. The triangular method, which we'll be looking at it, triangle method, parallelogram method, Cartesian, method, parallelogram, triangular, Cartesian method. So these are the methods we can use to solve vector. So let's see. Let's try the triangle. This is the rule. The triangle method or triangle rule states that if I want to produce this vector in a triangular form, if I'll assume this to be the first vector and this is the second vector, then I'll have this first. Now the second vector, the tail, because this is tail, this is head, the tail of the second vector will coincide with the head of the first and go down accordingly. You see that this is how it's almost forming a triangle. Alright? So now how would the resultant be? Good. I didn't want to tell you what resultant is until we see it. Now, these are two vectors, of course, and we want to represent it in a triangle. Obviously, a triangle is a three-sided shape, right?